Welcome to Rani Chemistry classes. In this video, I am going to discuss about the multiple choice questions in D and F block elements and coordination compounds. This is the weekend test 11 conducted by Board of Intermediate Education. The first one is the general electronic configuration of transition elements is option A n-1 D 1 to 10 ns 1 to 2 B n-1 D 1 to 10 C n-1 D 1 to 5 D n-2 F 1 to 14 n-1 D 0 to 1 ns 1 to 2. Transition elements means that is partially filled d orbitals. So option A is the correct one. The element that exhibit maximum oxidation number plus 7 is the given options. Manganese exhibit the maximum oxidation state plus 7 in 3D series, that is in the compound KMnO4. Here the oxidation state of manganese is plus 7. In 4D and 5D series, ruthenium oxide OSO4 exhibit plus 8 oxidation state. Next, third one, which of the following is colored in solutions? The ions which contains unpaired electrons can exhibit the color. So in the given option 1, Zn plus 2 zinc atomic number is 30. So its electronic configuration 3D10 4s2 plus 2 means 4s0. It does not contains any unpaired electrons, so it cannot exhibit the color. Next, titanium atomic number is 22, 3D2 4s2. 3D2 4s2. So plus 4 means it loses all electrons. So 3D0 4s0. It does not contains any unpaired electrons, so it also cannot exhibit the color. Next, option C, copper Cu plus. Atomic number of copper is 29. Copper is 29. So 3D10 4s1 plus 1 means 4s0. It also contains completely filled d orbital by the electrons, so no unpaired electrons, so it also cannot exhibit the color. Next, vanadium. Atomic number of vanadium is 23. So 3D3 4s2 plus 3 means first it loses 2 electrons from 4s orbital and 1 electron from d orbital. So 3D2 configuration. It contains 2 unpaired electrons, so it exhibits the colored. So the ions which contains unpaired electrons in the d orbital are exhibit color due to dd transition. Next, fourth one, coinase metals are copper Ag, Au or coinase metals. This belongs to normal elements, transition elements, active elements, high electropositive elements. These are transition elements. The alloy of copper and tin is bronze. Brass means copper and zinc, bronze, copper and tin, German silver, copper, nickel, zinc. So option B is the correct one. Next, which of the following ion is diamagnetic? So diamagnetic means which does not contains any unpaired electrons or completely filled orbitals by the electrons are diamagnetic. Chromium plus 2. Chromium atomic number is 24. 3D5 4s1 plus 2 means it loses 1 electron from s orbital and 1 electron from d orbital. So 3D4. So it contains 4 unpaired electrons. So it is paramagnetic. Vanadium 23. Vanadium 23. 3D3 4s2 plus 2 means 4s0. So it contains 3 unpaired electrons. So it is also paramagnetic. Scandium atomic number is 21. So 3D1 4s2 plus 3 means it loses 3 electrons. So 3D0 4s0. It does not contains any unpaired electrons. So it is diamagnetic. Next, option D, titanium 21. 22. The titanium atomic number is 22. 3D2 4s2 Plus 3 means it loses 2 electrons from s orbital and 1 electron from d orbital. So it contains 1 unpaired electron. So it is also paramagnetic. So option C is the correct one. 4D and 5D series D block elements have similar properties because diagonal relationship, lanthanide contraction, actinide contraction both belongs to the same transition series. 4D and 5D series of D block elements are similar properties because of lanthanide contraction, that is similar atomic radii. Lanthanum atomic number is 57. Its electronic configuration xenon 5d1 6s2. In 5d series, the first element is lanthanum, so it belongs to the d block element because differentiating electron enters into the d orbital. Next, ninth one, Miss metal is an alloy of 95% lanthanides, 5% iron with trace amounts of sulfur, carbon, calcium and aluminum. The given options lanthanides, actinides, 5 of series, transuranic elements. So option A is the correct one. Next, 10th one, the formula for magnetic moment calculation. Magnetic moment is represented by the symbol mu is equal to root of n into n plus 2, where n is the number of unpaired electrons. So this is present in option B. Mu is equal to root of n into n plus 2. So B is the correct one. Which of the following has orange color? K2CrO4, potassium chromate, it has yellow color. Potassium dichromate has orange color. Potassium permanganate has purple color. Potassium manganate has green color. So in the question they are asking orange color compound. So potassium dichromate, B is the correct one. It exhibit orange color. It is not due to DD transition because the oxidation state of chromium is +6. So it does not contains any unpaired electrons in d orbital. But even though it exhibit orange color, this is mainly due to charge transfer spectra, that is ligand to metal charge transfer spectra. Ligand means which has a capacity of donating a pair of electrons. So electron pair donor, electron pair acceptor, electron deficient species, proton donor. So electron pair donor is the correct one. Next, 13th one, COCl3 6NH3 reacts with excess of AgNO3. The number of moles of AgCl formed is. This is written in the form of complex CONH3 6 times. Cobalt has fixed coordination number 6. Remaining 3 chloride ions are written outside. It undergoes ionization forming complex. Total complex has 1 ion. So by losing 3 chloride ions, complex get plus 3 chloride ions. So by adding AgNO3, this Ag plus ions react with chloride ion forming 3 moles of AgCl, that is white precipitate is formed. So the number of chloride ions indicate the number of moles of AgCl precipitated. So 3 chloride ions, so 3 moles of AgCl is precipitated. So option C is the correct one. In COCl3 5NH3, the primary valence of cobalt is. In this complex is written in the form of CONH3 5 times. Cobalt has fixed coordination number 6, so one of the chloride ion is written inside, remaining 2 chloride ions outside. According to the Werner's theory, every central metal atom in a complex can exhibit 2 types of valencies, that is primary valency and secondary valency. Primary valency indicate the oxidation state, secondary valency indicate the coordination number. So primary valency indicate the oxidation number. So the oxidation number of metal in this complex is cobalt is X, ammonia is neutral ligand, chloride has -1. By using chloride, 2 chloride ions on the top of the complex, we will get +2. So X is equal to +3. So A is the correct one. Ethylene diamine is an example of NH2, CH2, CH2, NH2, NH2, CH2, CH2, NH2. So ethylene diamine is an example of, that is, bidentate ligand. It contains 2 nitrogen atoms. So it is bidentate ligand. Options given are monodentate, bidentate, tridentate, hexadentate, ligand. It is wrong. That is spelling is mistake. Ligand. This is ligand. So bidentate ligand is the correct one. The hybridization in octahedral complex. Octahedral complex means coordination number is equal to 6. It undergoes either sp3 d2 hybridization or d2 sp3 hybridization. So in the options given, sp3d, sp3d2, dsp2, sp3. So option B is the correct one. The oxidation number of iron in K4FeCN6 is, the oxidation state of iron is considered as X. Cyanide ion has -1, 6 cyanide ions, so X minus 6 equal to, by losing 4 potassium ions, complex get -4, so X equal to +2. So the oxidation state of iron is +2. The UPAC name of NiCO4 is, this is carbonyl complex. CO is neutral ligand. In any carbonyl complex, the oxidation state of the central element is 0. So tetra, CO means neutral ligand, carbonyl, tetra carbonyl, nickel 0. So this is the correct one. Remaining are absent because oxidation states are given some values. Next, 19th one. Which of the following is not ambidentate ligand? Ambidentate ligand means the ligand containing two donor atoms, NO2, ONO. In NO2, donor atom is nitrogen, ONO minus, oxygen is the donor atom. Cyanide, Cn minus, Nc minus. CO is neutral ligand, SCN, NCS. Okay, so A, B and D are ambidentate ligands. The question they are now asking, not ambidentate ligand, that is carbonyl. CO in this complex, this is the mistake, that is CO, NH3 5 times Br SO4. This complex exhibits which type of isomerism? Ionization isomerism means exchange of the atoms or groups between the coordination sphere and ionization sphere. Hydrate isomerism means different number of water molecules between the two complexes. Linkage isomerism means which contains, that is ambidentate ligand. So ionization, so this exhibit the ionization isomerism. For this, the another isomer is CO, NH3 5 times SO4 bromine. So option A is the correct one.